Hello, today I'm going to show you how to use libcurl and curlpp to do HTTP requests in C and C++ respectively. The documentation for libcurl, this is a C library, is on the screen here. So to get started, we need to clone and build libcurl, and then after we do that, we're going to do the same thing with curlpp. Curlpp is a wrapper around libcurl, so libcurl is a dependency of curlpp. So first we need to install and make sure we can use libcurl properly, and then we'll move to curlpp. The first thing we do is make a fresh directory, and then we need to download the source. I have a little script here, but I'll do this step by step. Let's download it and then untar it, and then we're going to go, this is what we just downloaded, this is all the source, and we have a docs folder. In the docs folder there is a set of instructions called install.md. That's a markdown file that tells you how to install it, and the instructions we're going to follow is here in the Unix section. So we need to configure the makefile, and we're going to tell it to build with OpenSSL, and we're also going to tell it where we want to install it after we build it, and then we'll do make and make install in order to build all the libraries and put it in our preferred install location. To configure, we do configure OpenSSL, and then we also have this optional prefix that we can give it to install it where we want. If you have root access on your machine or your operating system, then you can not specify prefix and it'll install it in /user/local. That's the default location. But if you're on a university cluster or work cluster or somewhere where you don't have root access, but you still want to use this library, you'll need to install it somewhere else, somewhere in a space that you control that doesn't require sudo access. That's what I'll show here. So the first step is to configure it, and we're going to do configure. So we're in here and configure OpenSSL, and the prefix where we're going to install it is going to be in here. I'm just going to make it like in the parent directory here, and I'll call this folder curl 880 installation. Oh, I hope this is showing. Okay. So now it is configuring the makefile. And this is going to take a few seconds. Okay, now that it's done there, we can do make test is going to, that takes over 10 minutes to run, so I'm going to skip that step. But we can go straight to make install, and this is going to, oh wait, no. Wait, we just did configure, right? All right, we just did configure, so now I have to do make. This is going to take a few minutes to build all the libraries, so I'm going to hit make and then cut this section out. I just cut out all of the build stuff, but now if I run make install, it is going to put everything in this directory that we told it to, which is going to be up here in the curl installation. And so this has the lib inside the lib directory. This has the library files, and we also have the include directory here, which has curl, and then all the headers are in there. Also, in the docs folder here, we have examples, and the one that we're going to run is going to be called simple.c. And this is the easiest thing you can do. We just make an HTTP request, we get the result, and then print it to the screen. So I copied over this source file into a separate project, and so now that's here. And I changed the website we're querying to be a database of cards for Lord of the Rings Living Card Game, because I know what the result is going to look like. And now we have to build this using our installation location. So here I have a makefile, and I have this variable installdir for this folder, and then a subfolder in there is going to be our installation of libcurl. So libcurl install is going to have an include folder and a lib folder. So our simple.c, I copied it and called it libcurl example.c. That's our source file. Ignore the C++ stuff down here. We're just doing libcurl and C right now. So we want to build it with GCC, and we're going to call the executable libcurl example.x. This is our source file, and we do -i include directory and -l. This is the lib folder, and the name of the library is libcurl, so you do -l curl, and this will build it with static linking of the libcurl library. If I call the makefile now with make libcurl, then it will build this executable, libcurl example, and if I run libcurl example, it sends the HTTP request, and the server sends it back this JSON, which has information about this card, which is Aragorn, and it has all of his stats, attack, defense, health. This is a successful request from the server. Great, so that's libcurl. Now, if we want to use curlpp, which is a C++ wrapper around this, we need to install curlpp. Let's do that. So we're done installing libcurl. To get curlpp, we can get that from GitHub. I have a separate script for that. Here's the Git repository. I will clone the Git repository. Make this text a little bigger in the terminal. And now we have curlpp. And if we go in there, this has a CMake file that allows you to build the library. So we're going to build it with CMake. Let me create a build directory. And we want to call the CMake file from the parent directory, but we need to give it a few pieces of information. We need to tell it where, because it depends on libcurl, we need to tell it where libcurl is installed, and also where we're going to want to install curlpp. So we do that with these flags, libcurl include dir and curl library. So the command is going to look like this. So let's do this one at a time. Oh, we don't need that twice. So where we're going to want to install this, I'm going to install it in kind of the same folder, but I'm going to call this curlpp installation. So that takes care of our install prefix. And then libcurl include dir is our include directory for libcurl. That's going to be in our curl installation /include. And then the curl library file is a full path to the library file for libcurl. So if we, it's not in include, it's in here. lib, and then it's called libcurl.a. And let's just double check that this is the right path. If I ls it, okay. So that is, let's double check this, cmake, and then the cmake file is in the parent of build, and then curl include directory is the include directory for libcurl. Curl library is this library file, libcurl.a, which is in that install directory. And at the end of the day, we're going to install curl cpp and curl, curl pp installation. So we run cmake to build the make file, and then we do make install. And if we've configured things correctly, that will create our curl pp installation. Installing, great. So it looks like it was successful. So if I look at the install location, this will be curl pp installation, and that has our lib, include, and bin. So there's our shared object file for libcurl, and let's look at our headers. So we have a curl pp. Great. So in this make file, I have paths to the libcurl installation and the curl cpp installation. Or let's also look at the examples. So here, once we git clone it, there's an examples folder, and there are 26 examples, and example 0 is super simple. This is just using a minimal program to get an HTTP request and print it to the screen. So we've copied that here as curl pp example, and we're going to look at Ring's database again. We just need to compile this. In our make file, we're going to compile curl pp.cpp and create this executable curl pp example.x, and we need to give it the include directories for both libcurl and also curl pp. So we have two -I's here, and we also need to give it the lib path to the directory containing the library for libcurl. So -L, name of the folder, and then -L curl. And here's the the -L curl pp. It will know to look for the curl pp shared object file, but we will, since this is dynamic linking, we are going to do that at runtime. Why is that? When we built our libcurl executable, this used static linking. For some reason, when we compile this curl pp example, it uses dynamic linking. So we give it the both include directories and both libraries, the path to the library folder as well as the name of the library, and now we can compile our C++ example with curl pp. So we make that target, and we have our curl pp example.x. And if we try and run it, what happens is that it says we cannot open the shared object file. It's using dynamic linking to the curl pp library, but it can't find it. And it's trying to find it at runtime. The solution there is to add that library folder to LD library path. Just for this example, I'll just overwrite the whole thing. For this invocation only, curlpp installation /lib. So now LD library path knows to look in that folder to find shared object files, and it finds it. It runs curlpp, and we have a successful run of an HTTP request in C++. And that's how you do it in C and C++.